Hey everyone, so today we're going to solve this problem, that is LeetCode 1822, sign of the product of an array. It's a good problem, it's an easy level problem, not that difficult, and it has 1.6k likes, which is a good count. Now there is a function that is sign func that returns 1 if x is positive, minus 1 if x is negative, or 0 if x is equal to 0. You are given an integer nums, let product be the product of all values in the array nums. Okay, so basically the x is the product of all the numbers that are given to you in this nums vector or array, right? Now there are two things. The naive method, the very basic naive method will be that you have these products minus 1, minus 2, minus 1, minus 2, and minus 3, minus 4, 3, 2, 1, right? You have these items, you have these numbers, and you will start multiplying with them with each other. You can do that, but if you go to the constraints, you will realize actually the constraints are also not that big. But in an interview, if the constraints are obviously not given, and this problem is asked 45 times in Microsoft, which means that obviously the interviewer is like, okay, Konark, you have shown me the way that you can multiply all of them, and if the product is a negative number, you will return minus 1. If it is a positive number, you will return 1, and if it's 0, you will return 0. But is there any other way where you can handle some edge cases? Now the edge cases will be where you have, the in an array, let's say there are 10 raised to the power 5 element, because that's a general array size, and every array is the maximum number, which means somewhere around 10 raised to the power 9. Now if you will multiply 10 raised to the power 5, I mean, if you have product, and this will be, 10 raised to the power 5 raised to the power of 10 raised to the power 5, and this is not, like, this cannot be done. Like, I'm not sure if it can be done in Python, because Python has some very flexible, you know uh, like data typecasting and all that. But in most of the languages it will be an issue. Even in Python the memory issue will be there. So the best part is, because the problem has not asked, it's not asking us to make, to product the elements. What we can do is make an observation that if we have, let's say, if there are x number, or if there is a negative, just let's take this case. If the negative numbers are odd, there are two possibilities. If we have negative numbers and they are odd, if they are odd, the product will be odd, right? Product will be negative. And if they are even, they will multiply with each other, and they will form positive and positive, and positive and positive multiply with each other is positive. So the product will be positive. And if we have only one zero, and if there is one zero, only one zero, then the whole product is, if there is only one zero that is greater than zero, then the whole product will be equal to zero. So these are the only conditions that we need to take care of. So let's start. So now we have these variables, and that is positive. You know what, we don't need to calculate positive. We have negative, that is equal to 0, and then we have zeros, that is equal to 0. Now we will start our iteration. Let me take a reference to speed things up. And now if num is equal to 0, then zeros plus plus. If num is less than 0, then negative plus plus. Now at last I will say, if 0 is, if the value that we have is greater than 0, then obviously return 0. But if it is not, um, if we don't have any 0 value, but then we need to make a check if the negative value is an odd number, which means the modulus with 2 gives you the remainder as 1, then it means it's a negative number. Otherwise it's a positive. Otherwise the product will be positive, and you have to return 1. Okay, zeros. Okay, cool. Test cases are working. Let's see if this will be submitted. Okay, it is submitted, and it is performing not quite good. But let's see. Yeah. And this is very annoying. I mean, Do tell me if you also find this thing very annoying that sometimes it's 92, sometimes it's 27. I mean, come on, the time complexity is same, the code was same. Yeah, now the time complexity for this case, because we are counting the elements, we are traversing each and every element, so it's linear time. And space complexity, we are not storing, anything linear, so we are using variables, and that's constant space. So this is a space and time complexity. And the brute force way would also be linear time, but there will be some, variable typecasting memory issues, that how can you store such a large number, then you have to use string to store them. And the space complexity will also be affected, because to store a number in a format of string, and when you have large numbers like in this case, then the string length could be even more than the 10 raised to the power 5, right? Because if you have something like this, the 10 raised to the power 9 raised to the power of 10 raised to the power 5, that's a huge number. That's a huge number. And this will take like a lot of string, characters. Although memory will not be such an issue, because int type array will have 4 bytes of, you know like every element is 4 bytes, but in string every character is 1 byte. Still, like, the space complexity will be uncertain, and you don't want to, provide an uncertain code for production, so obviously this is a better approach. So that's it, that's the problem. If you have any doubts, you can ask me, and thanks for watching.